Iris for today.
Hey guys, my name is Iris and I am an 11th grader and I'm from San Diego, California. So today I am going to be teaching our class, which we have today is called Crime Busters. So yeah, and some of you might know it because it is a Science Olympiad event that is pretty popular, I would say. So if you do take that event, this information might be kind of repeated or you may know some things, but I'll try to add some fun things in that you may not know already, and hopefully you guys have a fun time learning and you guys enjoy it. So the first week we are going to be learning about chemical analysis, and well, first I'm going to be doing kind of an intro to the class and an intro to like what Crime Busters is, what like forensic analysis is, and like what we do. And then we'll get into more like chemistry stuff and like pretty cool things that people like real scientists use when they are helping solve a crime. And feel free to like use the chat, or like you can unmute yourself and ask questions, or like if you have any input, just yeah, feel free to add on. Okay, so here is a little introduction of what we're going to be doing throughout the 6 weeks. And so the first week today, we're going to be doing an intro like I talked about, and we're going to be learning a little bit about like different metals that you could potentially find at a crime scene, and then how they could be used to like solve crimes, like figure out a suspect. And then next week, we're going to be continuing along with our chemical analysis. And we're going to be learning about like powders and liquids and how those can help you. And like some discussion about how like we use these powders and like what they are used for. And then so I'll be like giving you some descriptions of like suspects of a crime, and you can help me decide like which powders or liquids like implicate them in a crime. And then for week 3, we have like more things like hairs and fibers, and it's really cool to learn the structure of those. And then I think we're skipping a week for Thanksgiving, so remember that. And then for week 4 is DNA. So DNA is a really cool method of that people use for like solving a crime, and like everyone has unique DNA, so it's like pretty useful. And one really important technique is gel electrophoresis, and I don't know if you guys have heard of that, but I'll be going into more depth about that. And then week 5, we have fingerprinting and footprints and the different types and how that is analyzed. And for the last week, I'm thinking about doing like a whole like kind of crime scene. I'll like give you suspects and then different evidence that can be found there. And then you guys can like help me, and we'll like try to put together who's the actual suspect. So I think that'll be pretty fun, using everything we learned from like the other weeks. Okay, does that sound good? Does anyone have any questions about what we're going to be doing? Okay. Okay, so we're going to start off today with learning about what exactly is forensics. So Crime Busters is basically the science of forensics. And you may have heard this word before, like, I don't know if you guys like watch different like TV shows that have, that they like solve crimes. Like I love the show Criminal Minds. I don't know if you have heard of it, but there's definitely the use of forensics in it. And so the formal definition of forensics is the application of science to criminals and civil law. So that's pretty like broad, I would say. So basically it's the use of like any science. So like I know today we're going to be talking a lot about like chemicals and how that is used in science, and then how that is used to like solve a crime. Could be like robbery, kidnapping, murder, anything like that. So here are kind of more steps to how the process of forensics works. And first, we have the examination of physical evidence. So that's like kind of what we're going to be talking about mostly today. And physical evidence can include any range of things. We have like metals, like maybe you found a little scrap of metal in the corner, or like someone spilled something, so maybe it's like a liquid. And then even like hairs or fibers that you find in the corner, like you could find your suspect's hair just like lying on a table or something. That's all included in examination of physical evidence. And then in examination of physical evidence, like there is just like observation where you use your eyes or a magnifying glass to examine physical evidence. But also we have administration of tests, which is more of like the chemical aspect, I would say, because you can't really just like tell what something is just by looking off at it while it's like a chemical. So there's a lot of different like reactions we can perform that goes with these chemicals, and by observing these like chemical reactions, we can tell what kind of like chemical it is. And then interpreting of data is like seeing what actually happened in your reaction, and like if something reacted or not. Or it's like DNA, you put it in a gel electrophoresis and you get your gel, and then you have to compare it to those of your suspects, and you're interpreting that data. And then another very important part of forensics, and any science for that matter, is clear and concise reporting. So you can't just like perform all your tests and then what do you do with it? So for sure, one thing is clear and concise reporting. So you want to like make sure to write down all your data, all the tests you've done, everything that all the results that you are given, and then report that. Okay, and then of course there's also truthful testimony of a forensic scientist. So you want to make sure, because you're like investigating crime, it's very important that it's truthful and you're not like incriminating the wrong person or purposely trying to make someone else look guilty, because that would not be good, especially in a court case or something like that. Okay. So that's an overview of forensics. Any questions so far? Okay, so here we are going to start off with an introduction to atoms and chemicals. So an atom is the smallest unit of like a chemical. So basically everything on the periodic table you have is an element and is one singular atom. But obviously they can be, multiple atoms can be like placed together and that will form a molecule. So well, we have an atom, and atoms are, this is like a good kind of picture of what an atom is. And it is made up of protons, neutrons, and electrons. And so a proton is positively charged. they are in the nucleus of the atom, as well as the neutrons, and the neutrons are neutrally charged. So neutron, neutral, there's no charge to them. And then electrons are what take up the majority of the space of an atom, and they will revolve, kind of make orbits around the nucleus of the atom, and they are usually negatively charged. And so then I talked a little bit about it earlier, but a molecule is a group of atoms. And you probably know this is a very famous molecule. It is water. We definitely need water to survive. And does anyone know what kind of atoms these are? Like, I know we have like the abbreviation for this, but does anyone know what the actual atoms that make it up are? Yeah, Angela, go ahead and answer.
Hydrogen and oxygen.
Yeah, so hydrogen is the H and oxygen is the O. It starts with that letter. So hydrogen and oxygen are both atoms, and they make up the molecule of water. So we're going to be going more into depth about hydrogen, or the atoms and elements of the periodic table. Okay, so this is thallium. I don't know, maybe you guys have heard of thallium, but it is an element that is on the periodic table. And so are hydrogen and oxygen, and everything that's on the periodic table is an atom. So here's some basic information about all your periodic table elements. So usually in the top left corner, you have the atomic number, and that shows you the number of protons and electrons in that element. So on the next slide, I'll just go onto it. But this is your basic periodic table, and it is organized by the atomic number, which is in the top. Well, right here it's in the center, but it'll be usually at the top, and then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And yeah. And is thallium poison? I am not sure, but it is number 81, so it might be. I have no idea what it actually is, but we're just using it as an example. So that's how the periodic table is organized. And then at the bottom, we have atomic mass, which is how much one atom of it weighs. And it's measured in atomic mass units. So it is much lighter than anything you probably know. Like if you know like a gram, it's like thousands of times smaller than that. So how we calculate atomic mass is by the number of protons plus the number of neutrons in that molecule. So like thallium has 81 protons and 81, or it doesn't necessarily have 81 neutrons, but you would add that together and get the atomic mass. But you might notice that 204.383, like, does it have a fraction of a proton or a fraction of a neutron? No, it does not. But the way we get this number is there's something called isotopes. So like the identity of an element depends on the number of protons. So we can't have like thallium with like 80 or 82 protons. That would not be thallium anymore. That'd be a different element. So we could have different, we can have thallium with different number of neutrons, and that would change the mass. So the mass that's on the periodic table is usually like the proportion of how much of each mass there is. So for example, if like 50% of thalliums weighed like 204 atomic mass units and 50% weighed 205, then the average would, or like the middle would be 204.5, and that would be what's on there, but that's not the actual number, but that's like kind of just how they get that number there. And then on the top right, that's like not on very many periodic tables, but we're just going to talk about it. And it's like the charge of the ion that it would be. And usually only like metals or like, well, yeah, usually metals are charged because they like to like lose an electron. And if the number is positive, that means they lose an electron because electron is negatively charged, right? So it loses the electron and then it becomes more positively charged. And then, so thallium could either lose 1 or 3 electrons and it'd have a +1 or +3 charge. And that's how you get that. Okay. And then if it has a negative charge, that means there's more electrons. So it gained an electron from somewhere else. Like, for example, if thallium lost an electron, then something like chlorine like wants an electron. Okay. And here's just an example of a periodic table. It doesn't have all the information on it, but there's definitely a lot online that you could look back at. Does anyone have any questions about periodic table, elements, anything? Okay, cool. Next. Chemical reactions. So this is like kind of the important part of how this information about the periodic table relates to crime busters. So a lot of the times in crime busters, we'll use chemical reactions. So we'll react like something we found that we don't know what it is and observe the reaction. And that's how we figure out what kind of molecule it is that we are reacting. So how a chemical reaction works is basically it shows how molecules or atoms react to form and the products they form. So here's an example. NaHCO3 and HCl, and it makes NaClH2 and CO2. So this is something we're going to be discussing more next week, like this, but in case you didn't know, NaHCO3 is sodium bicarbonate. And you're probably like, what's sodium bicarbonate? But it's more commonly known as baking soda. So you guys probably all have it in your kitchen or something and have used it to like bake stuff or cleaning. So it's really common. And one test you can do when you have this and you react it with an acid. So one of the most famous acids like we use in labs and in crime busters is hydrochloric acid. And it is added to baking soda. You'll get gas released like carbon dioxide and hydrogen gas are both gases, and you'll be able to see a bubble, and that's like a really cool reaction you'll be able to see. And then something important to keep in mind for chemical reactions is how we balance the chemical reaction. So we make sure that based on the conservation of mass, in your reactants and in your products, you have to have the same number of each element. So, so here you can see that in the reactant, you have 1 sodium ion, and then in the products, you also have 1. And then here, so you have 1 H, 1 hydrogen, and 1 hydrogen here, and that forms a hydrogen gas, which it's kind of cool because hydrogen by itself is an atom, but when you have the element hydrogen, it is always found as H2. So that's like the gaseous form of hydrogen, and it'll always form H2, and that would make it a molecule instead of an atom now. So yeah. Okay. Okay, so here are some common metals that you could find like at a crime scene or just like anywhere in your daily life. It's like pretty common. Okay, so the first one we're going to be talking about is iron. And iron, one of the very like key ways you can determine what iron is through magneticity. So iron is magnetic. So if you like put a magnet to it, it'll be attracted. And then you can see with that, it just makes it magnetic. So iron is also used to make steel, and steel is like an alloy and it's super strong and is used for building things. So like construction uses iron a lot. And then, okay, so how we use this stuff in Crime Busters is, so you're given a suspect maybe, and then they'll give you a little description about this person. So maybe this person will say like, oh, um, uh, David is a construction worker. And then they'll be like, oh, at the crime scene, there was this really like magnetic, well, since we can't be in person or anything, but like it'd be really cool to be able to test it yourself and you just given a random metal. But for now, we'll just like give you a description like, oh, this like magnetic metal was found. Who might this metal implicate? And it'd be like David because he works in construction. And in construction, they use steel, which is made out of iron. So that could implicate him. And another use of iron is in cell phones. So maybe iron isn't always going to be like a person who is in construction because pretty much everyone has cell phones. So there is always a chance that iron will be found because of anyone. Okay, next we have magnesium. And magnesium is never found in nature, but most of these metals actually your body needs them, like iron and magnesium. They're all in the food you eat. Like next time you can check your nutrition label of the foods you eat, and you might notice that they have like magnesium or iron. Yeah. So one cool fact about magnesium is that it is actually never found in nature. So it's like made, and one really easy way to detect magnesium or is that it is super duper unstable. It is one of the most, or it is unstable, unstable metal. It is one the most unstable that we're going to be talking about today, but there are definitely more unstable metals out there. And it will react with water, so it'll form a gas and it'll start bubbling. And magnesium is used in camera casing, planes. So maybe if you're a person loves photography or is a pilot, that could indicate that magnesium is something you would find on them. Lastly, we have, or for this slide, we have copper. Do you have a question? Okay. Never mind. Copper is copper colored, and in case you didn't know what copper color is, it's like orangish brown. Pennies are copper, so that's like the color that copper is. A super cool use of copper is that it never rusts. And so it is a superconductor. So it is used in electric wiring, pennies, like I said. So I guess if your person is like super into collecting coins or is like an electrician, copper would be one of the most likely things that will be found on them. Okay, any questions about these metals? Do you guys have you guys heard of them before, or do you guys like know some other uses that you like to add? Okay. Moving on, we're going to be doing 3 more metals for today. Okay, so first we have gold, and you've probably heard of gold before because people are like, oh, it's the most like valuable. Well, probably like diamond, but that's not really gold. That's not really metal. So probably you have gold is your super valuable metal. So people probably won't be losing it, but maybe it's on accident and they just accidentally drop their ring or something. And then you could be like, oh, gold. So gold, one way to identify it is it's super shiny and it's obviously gold colored and it's like a yellowish, a darkish yellow color, I would say. And it's one of the most stable metals, actually. So that's something really cool about gold. And that's why a lot of jewelry is made from gold because it doesn't really react with many things. So like it doesn't rust like iron will. And so it'll just stay in good conditions. So that's why if you get something that's gold and you start to see it rusting, that might mean that you're ripped off or something because usually gold stuff won't get rusted. And so it is used in jewelry and a lot of ornamental objects, like stuff that you want to be like passed on for generations because it's not going to be destroyed. And then next we have aluminum, which is a really high heat conductivity. That means it can absorb a lot of heat and it'll like spread the heat. So that's why you've probably heard about aluminum foil before, and that's something you use in baking. And the reason why it's aluminum is because it has really high heat conductivity. And so it'll like keep the heat like in your baking items so that like it'll cook faster. That's also why like you wrap stuff in it when you like barbecue or stuff. It like makes the food cook a lot faster. And another reason why it's used in foil is it's really malleable. And malleable means that it's like easy to manipulate and you can like bend it and stuff. And that's why it is used for foil. And another thing it is used for is electric line, probably because it's also highly heat conductive, but a lot of wires you'll see are copper. And finally, we have tin. So, oh yeah, in case you haven't noticed, after all of these names, I have little like parentheses with like two letters in them. And these are what these metals are known as on the periodic table. So like SN is tin, which like aluminum is Al. Oh, that like makes a lot of sense, right? But tin is like SN, which is kind of weird. And I forgot why tin is SN, but I think it has to do with like it's like Latin name or something like that. And same thing with gold. It's like because there's probably another element that's like Ti already, so then it can't be Ti, or else you have two elements that are the same and then you can't distinguish them. So one key characteristic of tin is that it has slightly yellow tint. So tin is still a like silver looking metal, but if you look at it closely, it'll have a yellow tint to it. And it is used for a lot of alloys, which are basically like stronger metals, and it is formed with copper to make bronze. So like when you have like gold, silver, and bronze metal, that bronze metal is made from tin and copper. And then tin is used for making coins and in glass making. Okay. Any questions here? Okay, cool. Then we're going to keep going. Okay. So last thing we're going to talk about is how these metals react with chemicals, basically. So this is like part of the forensic analysis process where you perform tests and experiments. So one easy way to identify magnesium, if you're only given like these metals, would be that it's super unstable. So it reacts with even water. So what happens is that the magnesium, when it's added to water, will form magnesium oxide and hydrogen gas. So when we say it like reacts, usually it'll form a gas which is observable to the naked eye. So I'm going to show you an example later with magnesium and hydrogen chloride. But when it's with water, it'll form somewhat of the same reaction, but just less severe. And then iron, aluminum, and magnesium all react with acid. So for the purpose of like experimenting, we're going to say that we're reacting it with HCl. So acid is basically anything that has an H attached to it, which is your hydrogen atom. Well, it's your hydrogen atom, but it makes it an acid. So like HCl, Cl is chlorine, so this would be hydrochloric acid. Yeah. Okay, so you have your reactions with iron, aluminum, and magnesium, and each of them react with this HCl, and it forms a salt. A salt is basically any two ions. So you have FeCl2, AlCl3, and Mg magnesium chloride. Okay, so, and each of them produces hydrogen gas, which you will be able to see the bubbles coming out of it. So, okay, wait, let me talk about this first. See how like you have to balance the reactions though? So if you have like two H's over here and HCl is the only H you get, you have to have two of them. So that's why it forms a reaction. And this is how you can be used to determine each of these metals. So here is magnesium reacting with HCl. Okay. It's also talking about like reduction and oxidation. If you guys are interested, I could talk more about that in next week's class and prepare some, I'll give you some like examples. But basically what happens is that like magnesium becomes an ion. So first it is a solid atom and it becomes the magnesium 2+ ion by when you remove 2 electrons from it because it becomes positively charged. And then you give these 2 electrons to the hydrogen ions, which are originally positively charged. And then you add the electrons and it becomes neutral. So it becomes hydrogen gas, which is a neutral molecule. So that's what the reaction looks like. And we can look at this again, but you can see that it bubbles a lot here. And like, that's basically all the gas being released from the liquid after the magnesium is being added to it. So yeah, that's how it works when metals are reacting with each other. Okay. I think that's all we have for today. And we're gonna do a Kahoot on some things I taught today and some fun scenarios. So let me just pull that up real quick. Oh yeah, do you guys have any questions, first of all? Do you guys understand? Okay, let me change. Okay, here's the game pin and you can join it. Let me copy this into the chat. You want the Kahoot music? Okay, let me share my sound. Okay. Can you guys hear it? Okay. Who's this? Oh yeah, who's E and J and T? It's okay. I would prefer to have your real name, but if yes, this is a pretty cool emoji though. Okay, I'll wait like 2 more minutes for people, or not 2 minutes, like a minute for people to join. Fortnite. We have 2 Fortnites. How are you gonna know who's who? You, Fortnite. Is Fortnite dead? More Fortnite. Okay, does anyone else still need to join? Let me know if you are still joining, or else I'm gonna start. More Fortnite. Okay, we're gonna get started. Okay. You like Fortnite? Okay. First question. It should start off pretty easy. Yay. Okay. Good job. Pretty easy, right? Okay. Continue. Let's see who's in first. Oh my gosh. There's 3 Fortnites on our leaderboard. Okay. Well, these are like the same. Okay. Anyway, next question. Okay. So technically, like, development of theoretical possibilities is not a part of the forensics process. Like you may be thinking that's like making hypotheses or something like that, but that's more of like an educated like conclusion, and you're not trying to like guess some random thing and hope that's like the answer you get. But administration of tests is definitely a part of the forensics process. Like we want to like see reactions and stuff, and that's definitely something we want. So yeah, theoretic possibilities is not one of them. Okay. Oh, Jay. Okay. Next question. What is an atom? The smallest unit of a chemical is correct. And then they form molecules, right? They're like not as small. Ooh, we have a consistent leader so far. Good job, most of you got it. So proton is positively charged. I like to think of it as like proton positive and then neutron neutral. So that's how I remember it. Okay. Next question. What is atomic mass? Yes, okay. Number of protons and neutrons is correct. So most of the atomic mass of an element comes from the nucleus, and inside the nucleus is what is the protons and neutrons. And remember, the electrons are the ones that go around the atom. So those don't really take up very much mass, but they do take up a lot of space. And this should be just in case. Yeah. And okay, I'll explain the next question when we get there. Okay. Let's see if we can beat J. Who's J? We'll see at the end, I guess. Atomic number. Yeah, okay. So atomic number is the number of protons. And remember, last question was the atomic mass. And atomic mass is protons plus neutrons. And I know a few of you clicked like protons for atomic mass, but remember the difference. So mass is always greater than the atomic number. So atomic number is just protons, and that's how we identify each element. Oh, all the Fortnites are back, I see. Okay, next question. Yeah, okay, so the answer is copper, and most of you got that, so good job. Copper is used in like copper wiring, and like I talked about earlier, it's like super conductive and stable, so that's why it is used in for electricity and copper wiring. Yeah. I don't know. Okay. Fortnite is in the lead now, but like F-O, Fortnite. Okay. Next question. Okay, pretty easy, right? Because gold is used for jewelry, so jeweler, that's a hard word to say. Okay. Okay, next. Good job. So aluminum foil is used in a lot of baking stuff. So yeah. Okay. So yeah, the gas that is produced when aluminum touches an acid is hydrogen. And I can go back to show you the reaction that occurs. Let me go back here. So it's this reaction right here, right there. And basically, you have hydrogen, but it can't be carbon dioxide because we have no carbons or oxygens in this reaction. And it's not chlorine gas because chlorine is not, it's not made into a gas. It is part of this ion chain here. So I guess that's a good guess, but it would be a hydrogen gas. And that's the last question, maybe. Oh, just kidding, there's one more. Yes, it is magnesium, just like here on the side right here. Magnesium reacts with water and it's like super unstable. So that is why it reacts with water and it produces gas. Okay, podium, let's see. Fortnite, is it all gonna be Fortnite? Oh my goodness. Who's the top? Oh my goodness. Okay. Literal. Okay, so does anyone want to reveal who they are? Who are these 3 Fortnites? No one? Okay, that's so funny. So everyone on our podium is Fortnite, I guess. Okay. All right, let me close out of this. All right, let me just stop the sound.